right, so now we're going to go ahead and look at some more of these. Probably one or two more from our textbook. And then we'll look at a couple of simple ones just to make sure we understand some of the basics. So again, we're still in 4.1. 4.4 is a lot easier. 4.4 is very, very simple compared to this. This, I think, is one of the hardest sections, just because of all the different rules. Let's try question 147. And this is going to be on page 289 of our textbook. And this one again covers various rules. So we have a minus 4 a cubed b squared over 12 a to the 5th b to the negative 4th, all raised to the negative 3rd power. Again, there are a couple of ways of working with this one. You could just distribute that negative 3 through. I think that's the harder way to work it out. What I'm going to do is order of operations. I'm going to do the inside first. So we're going to try and break down the inside. So on the right-hand side, I'm going to write out the inside. And we're going to break this down piece by piece. Okay, so let's work with the numbers. We've got 4 over 12 and negative 4 over 12. That would reduce down to a negative 3rd. So we'll do those numbers first. Those can go together. Negative 4 over 12, that breaks down to a negative 1/3. So that's our first part. Next, we're going to look at our a's. And what do we have? We have an a cubed over a to the 5th power. And what do we do with these? We are dividing, so what happens to our exponents? Subtract, so that's going to be a to the 3 minus 5, which is a to the negative 2nd power. And what about our b's? We've got a, same thing. We've got a b squared over b to the negative 4th. That's going to be b to the 2, watch your signs, minus a minus 4. That double negative here makes it positive. So that comes out to be b to the what? 6th. So what does our final answer for that piece look like? Okay, if we put everything back together, we're kind of running out of room, so I'll write it over here. If we put it all back together, we've got that minus 1/3. We don't need to write the 1, so I'm not going to write it there. We've got a minus on the top. We've got a 3 down below. We've got an a to the negative 2nd power. And we've got a b to the 6th power. Is everyone okay with that? And you could put the 1 there if you wanted to. We really don't need to, so I usually don't. But you could put that there. If it helps to see what all the steps are, you can put that there because that goes back to that 1/3. Now we're going to rewrite it, which we did over here. And what do we do with that negative exponent? That negative exponent gets distributed through. And let's rewrite this now. Sometimes these get a little bit confusing with all the different variables that are involved. So if I distribute it through, okay, that negative just stays with that a. So we have a negative a. And then when I distribute through, negative and negative makes it a positive 9, doesn't it? Because negative times negative here makes that a positive 9. Then we have a b, and we've got 6 times a negative 3. 6 times a negative 3 is a negative 18. And then we've got 3 to the negative third power below. And again, you can do these in many, many different ways. But one piece has to have a negative component with it. Doesn't matter which one. It needs that negative component. Now, what do we know about negative a to the 9th power? Well, 9, what do we know about that 9 here? We know this 9 is what? Odd. Okay? And a negative number to an odd power, well, that then makes it what? Negative. So that's going to be a negative a, without the parentheses, to the 9th power. What else are we going to do? Well, we've got to move things around so we can break it up. So this b is negative. We do not want negative exponents. So if it's negative on the top, it goes down below. And this 3 is negative. If it's negative below, it comes up to the top. So anytime you have a negative, it just flips across that division bar. So negative numbers down below, negative exponents down below, let me say it correctly, come up to the top. Negative exponents on the top go down to the bottom. We've got one more step. What do we know about 3 cubed? 3 cubed is not 9. 3 cubed is 3 times 3, which is 9, times another 3 makes it then 27. So now we have a negative 27. A to the 9th power over b to the 18th power. And that is as far as we can possibly go. So we broke it all down into that. And that is as far as we can go with that. And I think, yeah, that was 148. Sorry, not 147. So 148. Sorry about that. Let me just make sure I wrote the right number down here. Yep, it all broke down. And let's make sure we didn't make a mistake somewhere. Okay, let's make sure we didn't make a mistake. Oh, I think I wrote something down wrong. Didn't I? Yep, where did I make? It's very easy to make a mistake. I just accidentally wrote down a wrong number. That should be a 2, shouldn't it? Negative 2 there. Sorry about that. Right, I just copied it down wrong is all I did. And that would make that then, that's 6 there, and it's still, whenever you cube a negative, it still makes it negative. Because that 3 out front tells you that when you cube a negative, it stays negative. Because you look at the exponent outside. So that gives you then that negative 27. A to the 9th over b to the 18th power. And what you basically look at is you look at, and I should have wrote it better, you look at this power, that 3 is an odd power. That's why it stays negative. You look at the outside, that odd power keeps it negative. So you always look at the outside, and very rarely do you have negative numbers, but once in a while you might. Let's look at a couple more. These are going to be much, much easier. Let's see if we can remember how this one would work. This one's easy. If I gave you this one, okay, this one has, and it's very similar to a homework question here. if I gave you this one to work out? There are easy questions in the homework and there's difficult questions. This is an easy question. What would this one be? Well, order of operations, exponents go first. What do we know about anything raised to the 0 power? So this is then 1. This is then 1 as well. And those add together to give you what? 2. That's all you need to do. Make sure you understand the 0 exponent rule. Let's try one more of these. Again, very similar. Let's say I put a negative in a different place. What would this one be? Slightly different. Going to get a different answer here. Well, parentheses tell me negative 10 to the 0 power. The negative is inside the parentheses, so that would come down as what? 1. Okay, this piece right here, what is it? 5 to the 0 power is 1, but there's no parentheses, so what happens with the negative? Negative drops down. And 1 minus 1 makes it then a what? 0. So you see the difference there. You've got to be careful with those parentheses. Again, there's a couple of homework questions like that. I think question 3 is just like what we did up here. And question 4, you just have to remember that negative is out in front. What about numbers with negative exponents? Let's try a couple of these to work out. Okay, well, we've got negative exponents and we don't want them. So we want to add these together. So 5 to the negative first. 5 to the negative first power, well, that comes out as a fifth, doesn't it? Right? Negative exponents go down below. What about 2 to the negative second power? Well, what's 2 squared? 2 squared is 4. It's going to go below because it's negative on that exponent, so that's going to be 1/4. Now we need to add 1/5 and 1/4 together. We can't clear our fractions, so we need a common denominator. So we're going to use a 4/4 and a 5/5. Because we have to have common denominators here. Make sure you see that's a 4 there. And 4 times 1 is 4. 4 times 5 is a 20. 1 times 5 is a 5. 4 times 5 is a 20. Those can go together, and that makes that then what? 9/20. And there's one question in your homework like that, and that's question 6. I think we've covered a lot of questions out of 4-1, and we can do more of them next time if we need to from your homework. But this is going to now finish up 4-1. 4-1, I think, by far and away, is the most difficult section. Just because of time, we're going to now look at 4-4, which is multiplying those polynomials. This section is very easy. So 4-1 was very difficult. 4-4 is very, very easy. This one is by far and away much, much simpler. You're probably already familiar with a lot of the concepts here. but we're still going to go over it because we have to make sure that we can multiply these polynomials. So when we get to chapter 5, which is factoring, we understand how to factor. So much, much simpler. What are we going to do? If I gave you this question, I want you to use the distributive property. So all you do is distribute through. Numbers multiply together, and the powers are going to add. So 10 times 4, well, 10 times 4 is a 40. And what about the x squared? We have 2, and 3 more makes it x to the what? X to the 5th power there. And then 10 times 5 makes it 50, x cubed. That's it. That's just using the distributive property. Let's try another one. Let's see what we would do on this one. These do not make them more difficult than what they are. All we are doing here is distributing through. That's it. The exponents are going to add together, and the numbers multiply. So let's go ahead and take it piece by piece. Negative 8 times positive 3. Negative 8 times a positive 3, that makes it a negative 24. How many x's do we have? 2, and 2 more make it x to the what? 4. Do we have any y's here to go with it? Nope. So that's just a y to the 4th, and it stays there. Do we have any other z's to go with that? Z to the 5th. Nope. So that just stays as a z to the 5th. Next, negative 8 times 9. Negative 8 times 9, that's a minus 72. How many x's do we have? We have 2, and 1 more makes it x to the 3rd power. And then what about the y's? How many of those do we have? 4, and 2 more make it y to the what? Y to the 6th. Those add together. These exponents are going to add together. So there's your answer. All we are doing is using the distributive property here. Much, much easier than the last section. One more, and then we'll talk about the FOIL method. So let's look at this one now. Same concept, distribute through. You just distribute through term for term here. And the plus sign separates each one, plus or minus sign. So we're going to distribute through. So we've got negative 2 times 9. Negative 2 times 9, that makes it a negative 18. M's, how many do we have? We have 3. Add 3 more to it, so it makes it m to the 6th. Because exponents are going to add here. We're distributing through. What about the p's? 5 and 1 more makes it p to the 6th. Next, negative 2 times negative 2 makes it positive 4. M's, how many do we have? 3. and 2 more makes it m to the what? 5th power. What about the p's? How many of those do we have? 5, and 8 more makes it p to the 13th power. And what about the last piece here? Negative 2 times 4 makes it a negative 8. And then nothing else can go together. So we're left then with an m cubed to the 5th. So all we did was distribute through. We've done this before. Much, much easier than the last section. Distribute through, numbers multiply, exponents are going to add together. When we multiply, we also need to learn how to work with binomials and trinomials. So binomial means it has 2 terms. Trinomial means it has 3 terms. When we have, and we have done this before, our last exam had one of these. When we have a binomial times a binomial, we use the FOIL method. And when we talk about the FOIL method, the F stands for the first times the first. The O is the outside times the outside. The I is the inside times the inside. And the L is the last times the last. And we did a few of these in our homework in that 2-6. And we also had one of them on our exam where we had to FOIL. And FOIL works when you have a binomial times a binomial. So this is what we're going to work with first. So we're going to try this one. Now, 2 terms, right? Here. 2 terms here. That gives me 4 total, so I use the FOIL method. We use this a lot, so we need to make sure that we understand how to FOIL. So when we FOIL, we want to use the first times the first. Let me find a marker that works. Yep, this one works. So we use the first times the first. FOIL stands for first times the first for the F part. So 5 times 4 makes it 20. X times x makes it x squared. Then we do the outside times the outside. And you can do these in any order that you want, but I always try to follow the FOIL method. That way there's less confusion. So the outside times the outside. Well, 5 times 2 makes it a 10. There's no other x's, so that's just a 10x there, right? First times first, outside and outside. What's next is the inside and the inside. And that's negative 3 times 4. That makes it a negative 12, and the x comes along with it. And then finally, we have the last times the last. And that's negative 3 times 2. That makes it a negative 6. What do we notice here? These can go together because they're the same variable. And our final answer would then be 20x squared. Those can go together, making it a minus 2x and a minus 6 there. Is everyone okay with that so far? Does everyone see what I did there? Just use that FOIL method. Very, very easy. What about if there's something in front? if I gave you, let's say, a 5x cubed times 3x plus 1 and a 2x squared minus 9. Well, if I gave you this one, what we do is we FOIL first. So we're going to go ahead and FOIL it first. Before we do anything else, we'll bring down that 5x cubed, and then we'll distribute it at the end. So distribution goes at the end. So we're going to try and FOIL this out first. So when we FOIL, we've got 3 times 2. 3 times 2, that's going to be a 6. X times an x squared, that makes it an x cubed. That's your first times the first. Then we need the outside times the outside. So that's 3x times a negative 9. 3 times a negative 9 is a minus 27. And the x just comes along with it. And we've got the inside and the inside here. 1 times a 2x squared. That's simply a 2x squared. And then 1 times negative 9. That's a negative 9. I made this one on purpose to where you can't combine the middles together. Why can these not go together here? They can't go together because one's x and one is what? X squared. So they can't go together. Most of the time they can. All right? But I just made this example so you would see that that doesn't always work. Now, when I rewrite this, I'm going to rewrite it in the highest power of x first going down. So we always write that in descending order. So let's rewrite this in descending order as 6x cubed, 2x squared, minus 27x minus 9. And don't forget what's still out in front of all of it. 5x cubed. So we FOILed. We wrote it from the highest power of x going downward. That's the way we usually go. Is we pick a variable and write it going downward with that variable. Now we still have one step left to do. And what do we do now? We just simply distribute that 5 through. 5 times 6. Well, 5 times 6 is a 30. How many x's do we have? 3. 3 more makes it x to the 6th. 5 times 2 is 10. X cubed. And 2 more make it x to the 5th. 5 times a negative 27, we know that's going to be a negative, and I think that's negative 135. But let me double check and make sure. Yep, that's going to be a minus 135. X's, we have 3. 1 more makes it x to the 4th. And then finally, we have 5 times a negative 9. So that makes it then a minus 45. And the x comes along as an x cubed. So that would be your final answer on that. And FOILing is very easy, but we have to know how to do it without making mistakes and do it pretty quickly. We'll do 2 more of these FOILing problems, and then we'll move on to a bigger one. So let's FOIL this one out. So let's go ahead and FOIL this one out. Now, the variable doesn't have to always be an x. Variable can be a p, q, whatever it might be. Normally it's an x, but it doesn't have to be. We want to FOIL. First times first. 8 times 5, well, 8 times 5 is a 40. Watch the p's. How many do I have? I do not have p to the 9th power. I have p to the what? These add together. P to the 6th. So don't multiply them, add them. Next, outside and outside. So 8 p to the 3rd times 3, that makes it a 24. P to the 3rd. Inside and inside, that's a minus 5 p cubed. And minus 1 times 3, well, that makes it a minus 3. Always check. In this case, can the middles go together? Yeah. Why? Because they have the same exponents. The last one they couldn't. This one they can. So these can go together. And that makes our final answer then 40 p to the 6th. 24 minus 5, that makes it a positive 19 p cubed minus 3 on the end. That was another example of FOILing, so I wanted to do one where we have a little bit higher powers. And again, I think you'll find this section to be much, much easier. Let's do another one, and let's do one that has a power. This is a question that students make a mistake with all the time. Because what happens is, I guarantee that someone's going to come up and say, well, I can just distribute that square through. And we cannot do that. What we have to do for this problem is we have to FOIL it by writing it out twice. And then the very last thing that we do is multiply through. So the exponents always go first. Again, you cannot just distribute it through. What you have to do is write it out twice and FOIL. So what we have to do with this one is we've got 3p squared plus 5 quantity squared. That comes down to then 3p squared plus 5 times 3p squared plus 5. So I cannot distribute that square through. What I have to do is write it out twice. And now what can you do? After you've wrote it out twice, you can now apply the FOIL method. So we're going to go ahead and FOIL. First times first, 3 times 3 makes it a 9. P squared and another p squared. Add those together, makes it p to the 4th. Outside and outside, 3 times 5, well, 3 times 5 makes it then 15 p squared. Inside and inside is another 15 p squared. And finally, last times last. Well, what is that now? That is 25. Can these go together? Yes, they can. So that's going to be 9p to the fourth. These can go together to make that 30p squared plus 25. And we still have that 8p to the fourth left out in front. Is everyone okay with that so far? So make sure you follow your order of operations. What did I do first? And we're just simplifying here, we're multiplying. This is what you were given. You FOILed it out first. You combine like terms if you can. Now what do we need to do? After we FOIL, then what can we do with this 9p to the fourth? Or sorry, 8p to the fourth. Sorry about that. We distribute that 8p to the fourth through. And so 8 times 9. Well, 8 times 9 is a 72. We've got 4, and 4 more makes it p to the 8th. And then we've got 8 times 30. And that should be, 240. How many p's do we have? 4, and 2 more makes it p to the 6th. And then we've got 25 times 8, and I believe that's 200. That's going to be then a 200 p to the what? Fourth power. That's it. That's our final answer. How do you know when we're done? Well, we're done when there's no parentheses left. Because once we're done, there shouldn't be any parentheses. Nothing can be combined together. We're going to do one more, and then we'll take a short break. Come back and look at the larger polynomials. So let's do one more of these. And again, directions are simply multiply. Well, sorry about that. Let me write one that works right. We're looking at the wrong part here. Let's write this as 3x squared minus 4y squared. Sorry about that. Trying to create a different problem here. That's what we're going to work with. So let's try this one. So this is what we want to work with. Now this one has different powers, different variables. We've got 2 variables. That's why I picked this one. What do we do first? If we want to multiply this out, it's squared, so we write it out twice. And once we wrote it out twice, then what method do we use? FOIL. So we're going to go ahead and FOIL this out. This has 2 variables. That's why I picked this one. Just to make sure we looked at all the different scenarios that can happen. 3 times 3 makes it 9. X squared and x squared makes it an x to the 4th. Outside and outside. We have 3 times a negative 4. 3 times a negative 4 is a negative 12. And we've got an x squared and a y. Inside and inside is next. So negative 4 times a positive 3 Well, that makes it a negative 12. Again, x squared y. And then what about last times last two? Yep, positive 16y squared. Watch your signs. So that's a positive 16y squared. You have to be very, very careful with your signs. What can we do? Can the middles go together? Yep, those are the same, aren't they? So my final answer would then be x to the fourth minus 24 xy, that x is squared there, plus 16y squared. And that's as far as we can possibly go. How do we know we're done? Nothing can be combined together. All the parentheses are gone. We don't want any parentheses left. So I wrote it out twice, and I FOILed. Okay? Exponents, what do? Add together. So those exponents add when we multiply. So let's now take another short break. And let's meet back at 10:40. So meet back here about 10:40. And then we'll finish up this section.